So it's already 7 p.m. So hello again, everyone. Um, this is your host, Laura Zamora, and on behalf of the SUG officers, I would like to extend our gratitude to our speaker for accepting our invitation, and of course, to all of you, our reviewees. So before we start the review, we strongly urge everyone to actively participate during the discussion and answer the questions posed by our lecturer. If you have any questions, type them in the Zoom chat box or in the Slido link provided. So, without further ado, it is my distinguished pleasure to introduce our speaker for this evening. Please welcome our speaker, a geologist with a rich history in resource exploration. He began his career as a junior exploration geologist at Oro East Mining Company in Mati City, Davao Oriental, before advancing to similar roles at Philsaga Mining Corporation, where he focused on epithermal gold vein deposits and coal exploration. He continued his journey at Asia Alstron Mining and Development Company, honing his skills in copper gold skarn deposits. He then progressed to a more senior role at Philsaga Mining Corporation, supervising diamond drilling operations and geological interpretations. Since May 2022, he has been with Fubia Mining Limited in Lao PDR, where he designs and implements drilling programs and geological assessments for gold and copper prospects. Please join me in welcoming Sir Rojan Humuad. Sir,
Hello, good evening, guys. Oh, there are 42 participants. Thank you very much. First of all, thank you very much for inviting me here in this board review. It's a pleasure, of course, to serve as an alumni of USEP. Once again, my name is Rojan Humuad. I graduated in USEP in 2014, and same year I passed the board exam. So now I'm connected with Fubia Mining here in Lao PDR as a mine resource development geologist. Basically, we are doing exploration works, near mine exploration works, and also some regional exploration works. Okay, so now let us start. So everybody is good, I think. We have 43 participants. So I am tasked to do
Mm,
a hello board
oh,
review on mineral resources of the Philippines. So, wait a minute. I apologize first because I thought I can use my laptop. I'm using the company laptop and I did not know that we don't have Zoom. We're not allowed to use Zoom here. So I'm just using my phone now, but the secretariat will just be uh, doing the presentation. Okay. So next slide, please. I'm just gonna turn off my video. Okay. So for mineral resources of the Philippines, this is my outline. We're gonna have some introduction, some basic definitions that we have. We also have the role of mineral resources in our daily lives and in our as a professional, as a geologist, and a little bit of history and development of the study of ore deposits. And we will talk about a little bit of the stages from exploration, development, and eventually proceeding to the mining of mineral resources. And of course, we're gonna proceed with the metalliferous ore deposits with some general classifications and some examples, and the non-metalliferous deposits in the Philippines. Well, basically, those metalliferous and non-metalliferous deposits, I just based Geology of the Philippines, Chapter 3, for the and also from the Mines and Geosciences Bureau. Next slide, please. Okay, so why is it important that we must have to have a good knowledge or a solid foundation for metalliferous and non-metalliferous deposits? Because as a geologist, as a professional, if you're going to work, especially if you're going to pursue uh, exploration, development, and exploitation or mining you're going to pursue that path as a geologist, then you must have to have a good foundation for this kind of deposits, especially that the Philippines is one of the key center or key study center for these types of ore deposits. So mostly of these deposits that's being studied in the Philippines are metalliferous, meaning these are basically metal elements. Examples are the porphyry copper systems, gold copper systems, podiform chromites, the nickel laterites, and also we have several volcanogenic massive sulfide deposits. Next slide, please. Okay, so why is it important? Because the Philippines is actually fifth most mineralized country in the world. Even the Philippines is just a small country. The Philippines is relatively, compared to all other areas in the world, we are young in terms of in geologic time of formation. We're relatively young, but we are the fifth most mineralized country in the world. And there is still a $1 trillion worth of untapped. So hindi pa na developed, basically maybe not explored, not developed, or unmined metals deposit, specifically for copper, gold, nickel, zinc, and silver reserves. And only 5% of that has been explored for in the Philippines. And only 3% are covered by mining contracts. So as you can see, we still have a lot. So minsan kasi ang iba, they're thinking, medyo marami ng mina sa Pilipinas, baka wala na tayong makita. No, let us be optimistic, because basically, based on estimate, we still have at least $1 trillion worth of these untapped mineral resources or reserves. So why is it also important? Because as you can see, the Philippines has 30 million hectares in terms of area, total land area. Only at least 30%, almost 30% of the total land area of the Philippines are covered by mining tenements. And within that 9 million hectares, or 30% of the 30 million hectares, only 2.52%. Only 2.52% are covered by mining tenements. Sorry, I must have to go back. Again, 30 million hectares of total land area, estimated 9 million hectares, or at least 30%, 33% of the total land area has high mineral potential. And within that, it's only 2.52%, or that's 750,000 plus hectares, which are covered by mining tenements. So see, we still have a lot of areas to explore and to use our geological senses. Especially as geologists, we are the ones who are in the forefront of this exploration, development, and mining of these areas. How about economic contribution? As you can see, billions of pesos in 2023 and 2022, 2022, 2023, and also in 2024, the mining industry have contributed. For example, for taxes, fees, and royalties, 48.77 billion for 2022. And most important thing is, of course, employment. We have 200,000 Filipinos employed within the mining industry. And what else? Some people, of course, some environmentalists, they will say, "Oh, you're just all about economic contribution. You don't care about the environment." No, because based on our Mining Act, we are the mining companies. They are directed to have their own social and environmental protection and rehabilitation program. So say, for example, the Mining Forest Program, as of May 2024, the mining industry have contributed at least 55 million seedlings within 51,967 hectares of land. See, so the mining industry, I think, of course, we're still developing. So that is also one of our, as geologists, one of our responsibilities to have a sustainable future. So next slide, please. Okay, so these are some definitions. Ay siningit ko na lang dito itong mga definitions na ito. Just of course, because this is a review, so these are just definitions. One is ore. So what is ore? When you talk about ore, these are rocks and minerals that are mined, processed, and delivered. The most important words there is at a profit. So dapat kumikita siya. Diba? So we have the categories. We have the metallic, the non-metallic, and we also have energy and water. Actually, that's a that is an extended categories in terms of ore. But basically, when we talk about ore, mostly in the Philippines, we're just talking about the metallic and the metallic minerals, and extended to the non-metallic and energy and water. So when we talk about gang, it is within the ore that is non-valuable. So wala siyang value. May ore ka, but of course, not everything within your ore are of value. So this, we call that gang. For example, in gold veins are not just formed. Sometimes, of course, you'll see gold veins itself, but basically, generally, gold veins are formed together with silica and clay alteration. And if you're going to mine that, if you're going to mine the ore, you will also mine the gang minerals, which are silica and clay, because the gold is associated or deposited, precipitated within and together with the silica and clay. Next definition word is protor, or some say protor. These are mineralized rock that is too lean in ore materials to yield a profit. So for example, you have seen a mineral occurrence, and eventually when you explored it, then you'll see you found out, or you evaluated that it still at present time, at current market valuation, we cannot mine it or develop it or exploit it at a profit. Then it's called protor. It's just basically a concentration or a mineral occurrence. Then waste, it's also the non-valuable portion of the ore. Actually, it's the mining sense already. If it's technical sense in terms of mineral deposit, you say gang, and then if it's being mined already, the gang minerals are basically waste. So it's the non-valuable portion of the ore. The gang is the non-valuable minerals in the ore. So see the difference? Gang, non-valuable minerals in the ore. So basically, gang minerals are also waste minerals because these are also non-valuable portion of your ore. Does that make sense? Okay, am I clear? I mean, is my audio clear? Because I'm just using my phone. Can someone am I clear? Wait.
Yes po, sir.
Okay, good. Thank you very much. Okay, next slide, please. If you have questions, just write it and later we will discuss it. And I'll try my best to answer the questions. Okay, mineral deposit. Basically, the basic definition, it's the concentration of ore minerals. That's it. If you have ore minerals, meaning these are minerals that carry valuable metals, and it's being concentrated in an area, then you can call that mineral deposit. Now, when you say ore deposit or ore body, then you will apply now again the concept of ore. So what's ore again? Go back. Can you go back to the last slide? What was ore again? Can you please go back to that? So ore are rocks and minerals that are mined, processed, and delivered at a profit. Important thing is a profit. So next slide again. If it's ore deposit, therefore it's the concentration of that mineral deposit that can be recovered economically. Next, cut-off grade. So basically, these are jargons that we usually use when you are mining already. So it is the lowest grade or quality of mineralized material that qualifies as economically mineable. So say, for example, in Philsaga, if I'm not mistaken, I don't know if please correct me if I'm wrong, for the OJTs that were in Philsaga or did training in Philsaga. I think their cut-off grade there is 3 grams. Am I right? I forgot already. But I think that's it. So meaning, after 3 grams, below 3 grams, they can't be mined already. It's considered now quote unquote waste, or you cannot feed it into the plant. More than 3 grams, therefore, those are ore, then you can feed it into the plant. And another word is Clark of concentration. Basically, it's the average content of an element in the Earth's crust. General concentration of an element in the Earth's crust. It's average. Next slide, please. Okay, more definition. Syngenetic ore. So sometimes you can read in articles about these brilliant geologists. They write this syngenetic ore, epigenetic ore. So these are the definitions. Syngenetic, simple, ore formed at the same time as the host rock. So if you have a host rock, the host rock is forming then all together with your ore, or all together with the valuable minerals or valuable metals, then it is a syngenetic ore. If it is an epigenetic ore, it is formed, the ore is formed after the host rock. So you already have the host rock. You already have formed, for example, a sedimentary bed, and eventually hydrothermal fluids went in and then deposited, precipitated gold or silver or base metal deposit. So it is formed after the host rock was already formed. So that those are epigenetic ore. Hypogene ore. Simple. When you say hypogene and supergene, this talks about the spatial or the where are the ore in place or formed. So if it is within the earth, it's hypogene. Example, porphyry, epithermal, those are hypogene ore. If it's supergene or formed at the surface, for example, you have nickel laterites, right? Those are supergene ores, near formed at or near the Earth's surface. Primary ore formed either by magmas or fluids. And secondary ore formed as a consequence of alteration of pre-existing minerals. So these are just very simple definitions of these terms that we're using. No, as you can see, syngenetic and epigenetic, it's all about timing in reference to the host rock. Okay, hypogene ore, supergene ore, it's all about the location in the Earth's crust as to where the ore has formed. The primary ore and the secondary, it's about the genetic, where or how was the ore formed. So it's now having a genetic sense, because, for example, if it's in primary, meaning the fluids or the alteration or the hydrothermal fluids came from a magma or just a fluid, or if it's a secondary, it's a consequence or alteration of pre-existing minerals, meaning you already have those minerals and then they are altered again into another minerals. Next slide, please. Okay, so the role of mineral resources. It's fundamental, very fundamental in modern society, especially we are now in the age where everything is being built. I don't think, I had a debate once with my classmate in high school. He said, oh, mining, it's a very dirty industry. You just destroy, and like that. And I told him, okay, so do you support mining? He said, no, I don't support mining like that. He said, oh, we always say like that. But the problem, I told him, what phone are you using? iPhone. What watch are you wearing? For example, he has he's rich, so maybe I don't know what his watch is, but see, all of those things are basically products of mining. So that is the only thing I could say to people who don't support mining. They're basically hypocrites. Sorry for the word. Because everything that we use now, everything that we see now are basically, even if it's not directly, products of mining. So that's where that quote is. When it can't be grown, it must be mined. Okay. So it's also important for national development, for a government or for a society to be self-sufficient in terms of resources. And just some historical notes. The Philippines was actually top 10 country in terms of gold, copper, chromium, and nickel production in the 1980s. But today, I think we're still, but not the top already, but we're still there. We're still producing those, we're still good in terms of the production of those metals. Next slide, please. So exploration stages. Okay. So basic, the orange ones are the main exploration stage. So you have the grassroots exploration, you have the target generation, you have the target testing. And then if you target test and you intercepted good mineralization, you'll have a discovery. So grassroots exploration, what do we do? For example, you are in an area, you don't know where the mineralization is. You don't it's greenfield. That is our term for that one, meaning there is no sign of human activities that would tell you that there is significant valuable metals and minerals present in an area. It's greenfield, meaning you need to find where it is. So these are the things that you can do. For example, you do remote sensing, geophysical investigation, because this type of investigation will cover widespread, larger areas, and then eventually, if you can identify anomalies, then you will focus on that areas. So you'll have airborne geophysics, you'll have geochemical survey, actually regional geoscience or geochemical survey, meaning soil surveys or stream sediment sampling, stream sediment surveys, or regions per sampling. Okay. And then you go to target generation. So for example, after your airborne aeromagnetic survey, you have identified that, oops, there is an anomaly. What kind of anomaly? For example, you have a magnetic anomaly, circular magnetic anomaly to the west of the area. And then you'll go there. Of course, it's an anomaly. So you're going to check, you're going to map, you're going to see target generation. It said property generation, acquisition. Of course, you cannot do that when you haven't acquired the property first. And then, of course, do the semi-detailed geological surveys. And then target testing. When you map that area with a bullseye or circular feature or circular magnetic anomaly, and then you found out that you have good rocks with good alteration that coincides with the concept of a magnetic anomaly, and then eventually you do detailed geological survey, you do trenching, and eventually scout drilling. So that is where us geologists are very important, because we are the ones who have the foundation. Yeah, we are the ones who have the geological sense. That's a term that I really like. Develop your geological sense so that when you are faced when you go to an area and you're faced with all of these rocks, minerals, you will know what you are looking into. And eventually, after the scout drilling, additing, shafting, that is actually optional in the Philippines. We just do drilling, and then after we have drilled so much, and then we do that. After we scout drill, and then good planning of the scout drilling, a very good exploration team with a good exploration sense, and then you'll have a discovery. It said there at least 3 holes hitting ore over economic widths. I think that's now in our current setup. You will need more than 3 holes just to intercept, just to do a discovery actually. For our case here in Fubia, I'm very lucky that I am really with a good team, and we are exploring areas where there are already mineral resources. So for example, there's an area that we explored here now, have a mineral resource already in specific area. I won't say the area because I think I'm not allowed to. And then my team actually discovered the extension of that area at least 500 meters away to the southwest. And luckily, first 7 holes, we intercepted everything. So it's also about the discovery is actually also about serendipity. Because if we hadn't found that outcrop, if we hadn't had the strong foundation or strong geological sense that this outcrop might have something down deep, because the outcrop actually does not bear anything. We have a sample, it's a float of, for example, more than 3 grams, but it's a float. It's not within the outcrop, but when we drilled it, voila, a extension. Basically, it's still a discovery because it's an extension of the mineralization. Then, after the discovery, you'll have to delineate the deposit because as geologists, we really need to have models. We really need to have to see what is the morphology of the deposit, of the ore body. So there it comes now, the ore body modeling, the resource estimation, the metallurgical testing, mine scoping, everything. And then we go to feasibility study. And then we pass that to the mining team, to the miners. Next slide, please. Okay, so what are the mining stages? So first, it's just development. That includes everything from after the feasibility, you already have the resources, then you computed the resource, and eventually the mining engineers put in the modifying factors and they have reserves, and then develop that, do feasibility study, and then start mining. And eventually, of course, after the life of mine has been depleted, then mine closure. Next slide, please. Okay, so resource reserves categories this should always been. I believe you already know this. So what we just say I will discuss each of that later. But this is a very common figure. So from exploration results, these are just reports. For example, you go to an area, you map, you have an evaluation, initial evaluation. Not necessarily mean that it is of value, but it just has a mineral occurrence. So it just exploration results. Mineral resources divided into 3: indicated, inferred, indicated, measured, and or reserves. When the modifying factors are already being incorporated to your evaluation or the estimate, then you have probable and proof. Okay, next slide, please. Okay, so exploration results. Basically, these are just data, information, and reports. So if you go to an area, you see mineral occurrence, you record it, you map it, you made a report, you submit it, that's your exploration results. That does not necessarily mean that it has a value, but it's important for investors and the financial advisors to decide whether to proceed or not with the prospect. Next, mineral resource. Most important thing are those involved in words. In that area where you map, you had an exploration result, you have a report. If that area have or has an intrinsic economic interest, which is reasonable enough for the prospect to eventually proceed for economic extraction. So that's a mineral resource. So meaning you have now a mineral occurrence, concentration of mineral or material that is having an intrinsic economic interest. So for example, you have 2 areas. The other area, you have both areas have mineral occurrences, for example, for gold. But the other area is low grade, the other area has moderate grade. So both are mineral resources, but of course, in terms of intrinsic economic interest, you prefer the area where the grade is higher than this one. But for example, you have an area, the first area, low grade, but you will have, in terms of computation of mineral resource, you will have 10 million metric tons. And the other one, You have high grade, but you only have 50,000 metric tons. So this is a question for all of you. Which do you prefer if you are the investor or if you are the financial advisor of someone who wants to invest in the mining industry? Can someone answer, please? Is it the
Can you
first
repeat the
area?
choices po?
The first area, 20, you'll have 20 million tons, but low grade. The second area, you'll just have 50,000 tons, but high grade. For example, 20 grams per ton. The other area is just 0.5 grams per ton at 20 million tons. Sige daw. Do your math. So we will just choose which is bigger.
The first one, sir.
Okay. Of course, generally speaking, the first one will be bigger, right? But it also depends upon the priorities of a company. Of course, we want the bigger one, but if you're going to look at the other one, it's high grade, it's small, but it's high grade, right? And meaning the mine life, the development stage or the mining stage would be shorter also for the smaller ones. So it's just depend. But yes, you're correct. The first one is the best in terms of the two. But if you're going to look in a broader scheme of things, the other one is also good. If you want, for example, to just stay on an area at a shorter period of time, then you can get that 50,000 tons of that 20 grams per ton gold deposit. So the other one you can mine longer. The other one you can mine shorter but of higher grade. The other one you can mine longer but of lower grade. You choose. But basically, yes, correct. The first one is better. Okay. Next slide, please. Wait, so, okay. So inferred mineral resource, these are the types of or the categories under mineral resources. Inferred, the red ones are the most important terms. It's low level of confidence. So you already have the tonnage, you have the grade, you have the mineral content, but basically the level of confidence you have as a geologist is just low. You're not sure whether, for example, in 100 meters, this occurrence, this grade, this tonnage, this mineral content will still be present. Okay? Then, why do you have a low level of confidence? Because you are thinking based on your interpretation, based on your appreciation and valuation of the deposit. It may be limited or the quantity is uncertain and not reliable. That's what I say. For example, you saw an outcrop here, you drill it, you saw it 50 meters down deep, but eventually you see, oh, maybe the structure is pinch and swell. I don't know if this structure will still persist 100 meters away. So the computation, the mineral resource you will have there is, if you have a low level of confidence, will just be inferred. Okay, next slide, please. Indicated. Red, the most important terms are the red ones again, the red fonts. A reasonable level of confidence, meaning, oh, yes, I know because we map already, we extended the mapping, we did some drilling again, 100 meters away, several hundred meters away, and then we still intercepted the mineralization. So you will have an indicated mineral resource. So basically saying this is just base. Later, you will see that and later, I'll just explain that later. Okay, so the locations are too widely or inappropriately spaced to confirm geological and grade continuity. So still, it's all about spacing, right? So of course, the closer you are, the closer your drill holes are, the more confident you are that the mineralization or the mineral resource is there. Okay, next slide, please. Measured. So you already have a high level of confidence. The location of the drill holes, not just drill holes, the data is closely spaced enough. And that's why you'll have the high level of confidence. Next slide, please. So the inferred, indicated, measured, they're just basically based on your confidence as a geologist in terms of the spatial relationship, the spacing of the data, the nearer the data, the closer space your data is, the more confidence you'll have. Therefore, the higher you are in terms of your mineral type or category of mineral resource. Okay, ore reserve. So these are now the when we pass it to the mining people. So they're gonna incorporate the modifying factors. Very important. You will be familiar with that, even if you're a geologist, because as explorationists, it is also important for us to know about those modifying factors, because we are also we should know when to say that a project or a prospect is economically viable or can really be mined, can really be transformed into an ore reserve. Because some people, I don't know, this is my observation, there are prospects, even if they already have evaluated hundreds of drill holes, but then they do not, they think that they do not actually say that we should let that project go, because of course, if you let that project go and you don't have any project left anymore, then bye-bye for you. Bye-bye for your work, right? So there are some, and not all, but there are people who do that. So that is the thing that we should avoid as geologists. Let us be frank. Of course, job is important, but our integrity, our dignity as geologists, our integrity in our work should also come first. Okay, so all research, just put economic modifying factors. Then it has two categories. We have the measured, economically mineable part of either a measured or an indicated mineral resource. That's why you can see in the graph or in the figure a while ago, there's a map, there's a dashed map also, that if it's an indicated, you can actually transform it or push it into an ore reserve, as long as you have already incorporated in your assessment or in your evaluation the modifying factors. Okay, there are two categories, the probable ore and the proved ore reserve. Next, please. Probable ore, indicated in some circumstances, and measured mineral resources. And then minimum pre-feasibility study have been carried out. So next is proved. Next slide, please. Let's just pass. Okay, proved. Measured, it should be something from the measured mineral resource. So if it's proved, should be something from the measured, meaning you already have a very high confidence in your mineral resource. And then if you put your modifying factors, and then you'll see, and you'll transform it into a proved ore reserve. So still pre-feasibility study has been carried out. Okay, next slide, please. Okay, let's just do next slide, please. So geological modeling, resource reserve estimation. We geologists, we like models, so we consolidate the data and then we interpret it. And then, for example, you have a lithological model, then you put a mineralization model, like the alteration model. So that's, you learn that eventually if you're going to work already. So next, estimation method. After you model, then you estimate the resource. It's either use the old school polygonal estimation, you have the block modeling. Now you have AI resource estimation. I don't know if some of you have done OJTs in companies where they use Leapfrog. Very good software for not actually a resource, because some of our old timers in the Philippines actually do not like the result or do not like Leapfrog as a result of resource estimation. But still, it's a very good tool. Very, very good tool. Very helpful tool, for example, for exploration, because you can easily target, generate drill plans. It's all so next, important also for geoestimation is the geostatistics. Me myself, I find it difficult actually to do that. Variograms and kriging, I don't actually have that much experience with that one. So basically it's geostatistics, so that you will have a proper evaluation of the spatio-temporal data sets. You'll have a proper evaluation and you will see if your model have errors. That's basic definition of it. You see, it provides a value. That's under Kriging. So it tells you about if you have errors in your model. Next slide, please. Okay. Oh, so let's go now to these models. I just want you to see this. Basically, these are the ore deposit models for gold and copper, which is in relation to plate tectonics. And I don't know if you're familiar with that one already. I think you are, especially if you want to be exploration geologist. Next slide, please. Then we'll now proceed, I think, to the Pacific Rim, where it's called the Pacific Rim of Fire, but it's also called the Pacific Rim of Resources because most of the copper gold deposits and base metal deposits are concentrated within that area. Next slide. Deposits in the Philippines. We all know we all have a lot of mines and deposits in the Philippines. So next slide, please. Okay, so now we now go to the metalliferous deposits we have in the Philippines, in the metalliferous mineral resources. So one, we have iron, we have nickel, we have chromium, we have manganese, we have copper, gold, silver, aluminum, molybdenum, mercury, lead, and zinc. So the highlighted ones are, I think, the most important because these are the ones that the Philippines are actually quite popular of in terms of exports and studied occurrences in the Philippines. So it's nickel, copper, gold, and silver. Next slide. So iron. So what are the primary or the ores of iron in the Philippines? We have the iron oxide, the magnetites and hematites and limonites, the goethite, the siderite. Oh, by the way, one question. What is a siderite? Can you put the formula or the description of what a siderite is in the chat, or someone can answer? Good, nice. Nice, good. Okay, so in the Philippines, we have these iron deposits are classified into, we have the iron skarns, we have the magnetite sand, we have the laterites, we have deposits of iron in sedimentary beds or in sedimentary occurrences, we have bogs, and we have spring. But of course, the most important are the first three, the skarn, the magnetite sand, and laterite, because these are the major, the ones that are producing more iron in the Philippines. So next slide, please. Okay, so skarn. What is skarn? These are actually altered calcareous sediments because of the intrusion being intruded by intermediate to acidic Pluton, which also, of course, brings several other elements such as gold, copper, lead, and zinc. But there are several iron skarn deposits in the Philippines. You can study all of these deposits also in detail because there is also a specific environment or description of environment that skarn is occurring. So that's just the basic description, and you will see it that iron also is present in skarn because we have iron skarns in the Philippines, mostly occurring as hematite, magnetite, iron skarns. So next, magnetite sand. These are concentrations of magnetite, and beach and alluvial sand. Some of the economic deposits generally should have 15 to 30% magnetite, which could yield about 55 to 60% iron. Okay. Next, laterite, comprised of the superficial soil. It is just the weathering of the ultramafic and ultramafic rocks. So if it's overmafic, these are called aluminous laterites. And if it's ultramafic, these are called nickeliferous laterites. So we can also get iron from those laterite because usually we just know some of the people, they just know it as nickel laterites, but there are also a good concentration of iron in our laterites. Okay, next slide, please. Okay, sedimentary or bedded. So these are actually form of or layers of hematite and magnetite interbedded within the sediments. So if you have sources of this hematite or magnetite, or if you have oxidizing environments, then your during the formation of your sedimentary layers, then eventually it's lithified and became sedimentary deposits. Then you'll have this kind of occurrence of iron as again iron oxide minerals. And then sedimentary bog. Most important word for this one is the bacterial action. It should have an organic interference or an organic there is a bacterial action in the precipitation of your oxide minerals and hydroxide minerals, of your ferric oxide and hydroxide minerals, which are formed in bog waters and by streams and springs. So that's the sedimentary bog iron occurrence. Next slide, please. Springs. So basically, if you have emanations coming from springs in the volcanic terrains, where I think your iron have been leached from those host rock or the counter rock, and it has been redeposited as crust, massive crust and coatings in the boulders or breccia fillings in brecciated rocks in volcanic terrains, then you'll have that kind of deposit for iron. And the most important textural identification or textural identification of this is the colloidal textures, which may form crustiform bands or botryoidal textures. Okay, I have a little bit of question again. Give me an example of a mineral that is having a botryoidal habit. Can someone chat in? Can someone place their answer in the chat? Botryoidal. Okay, yes, correct. What else? How about a copper mineral that's botryoidal in texture? Yeah, that's correct, actually. Good. Yeah, correct. Very good. Wow. Nice, nice. Okay, next slide, please. Okay, nickel. Now we go to nickel. So these are the primary nickel minerals. We have the garnierite, you have the millerite, you have the niccolite, you have the pentlandite and pyrrhotite, and so on. But these are one of the most important in the Philippines. Okay, question again. So what is garnierite? I did not put because it has a very long what do you call this chemical formula. But what is garnierite in terms of, for example, if you say millerite, it's nickel sulfide. So what is garnierite? Can someone put in the chat what garnierite is? Just based on your stored knowledge, ha? Huwag kayong chat dyan, ha? Mag-search. So what is garnierite? Eh? Yes. So basically it's a nickel manganese hydrosilicate mineral. Okay, good. Yeah, that's that. Yeah, you can say that. Okay, so for nickel, Philippine nickel deposits are classified into nickel laterites, and we have the magmatic nickel sulfide deposits and the hydrothermal nickel sulfide deposits. So nickel laterites, next slide, please. Nickel laterite deposits derive from the weathering of underlying ultramafic, or some have mafic to ultramafic rocks found along ophiolite belts. Okay, so that's a straightforward description of it. If your ophiolite belts have mafic to ultramafic rocks, and eventually if it's abducted and then exposed to a superficial environment, and it became weathered, and eventually you will form nickel laterites. And then you have the nickel there, and you have that. That's what we discussed earlier. You also have iron there in your laterites. Next, the magmatic nickel sulfide deposit. These are actually formed as a result of liquid sulfide miscibility of a crystallizing magma. So you have a magmatic component. You have an affinity to a magma that is already being crystallizing, or that is already what do you call this? The term is on the tip of my tongue. It's crystallizing magma. So what do you mean by immiscibility? Sulfide immiscibility. Can someone please chat? What does immiscibility mean? Why do you have nickel and why do you have nickel? Why will you have nickel or other minerals where you have when you sulfide is immiscible in a crystallizing magma? Immiscibility meaning it's actually if it's still a magma, it's crystallizing. Yep. Yeah, that's a good description. Yes, meaning it's not mixed. It looks homogeneous, but it's actually not mixed. So basically, different fluids, different material that does not generally mix, and it's correct. It's actually not homogeneous in a sense. So it basically the term is it does not mix. So your sulfide in your liquid and your fluid does not mix. So that's where you form those nickel sulfide deposit in magmatic environments. Next, hydrothermal nickel sulfide deposit occurs in narrow silicified zones in serpentinite rocks. Okay, basically hydrothermal leaching and redeposition along fractures. So you can also say it's an epithermal kind of system because you have fractures, you have cracks where your hydrothermal fluid leaches your nickel minerals and then eventually redeposited it into fractures as veins or as alterations. Okay, next slide, please. Okay, nickel laterite ore types. Nickel is concentrated, of course, during lateritization of your ultramafics, producing two ore types. We all know if it's a saprolite zone, it is nickel-bearing silicates. This is where the ore is, right? The main ore is. But you also have the laterite ore, which is the nickel is absorbed into and included in goethites and other hydrospherosilicate. Okay, question again. What do you mean by adsorb? Can someone chat what does that mean? It said nickel in saprolite, you have the nickel bearing silicates, meaning your nickel your element is within your silicates, right? It's within the crystal system, or you really have a mineral that is present in the saprolite zone that is nickel bearing mineral. But when you say nickel is adsorbed, it's the laterite zone. What do you mean by adsorbed? What does that mean? Can someone message in the chat? Yes, you can say that. Meaning, it's like a thin film outside a surface, right? Correct, you're correct. It's just attached into your other minerals or hydrospherosilicates. Correct. Yes, that can be said. It's just nickel will just be incrustations in your minerals such as your hydrous aluminous iron oxides. Okay, next slide, please. Let's just next slide, please, for this one. It's just okay. So let's now go to chromium. So chromium is the mineral, the element, and chromite is the mineral, correct? So the types of deposits are classified into primary or orthomagmatic and residual and transported. So we also have different subtypes in terms of use. Now, the other one is in terms of genetics. Where does it came from? Where it is produced? The deposit, where the chromite deposit is produced or formed. The other type is in terms of use, which is in reference to the chromium and iron ratio of your chromite deposit. So if it's metallurgical, it should be at least 2.4 to 3.2 is to 1 iron. If it's refractory, it's at least 1.8 to 2.3 is to 1 iron. So 1.8 to 2.3 chromium to 1 iron. And if it's chemical, I don't have the definition for this one. I tried to search actually, but Let's just try to search that one also. What does that mean? But basically, I think it's lesser than the refractory one. Meaning chemical, you will what do you call this? You will recover it using more chemical processes. I think that's what that means. Okay, next slide, please. So definition for primary podiform deposit. These are basically primary deposit or formed with primary igneous processes. So meaning when your magma, your ultramafic magma is or ultramafic units are being formed. And this is also where your this podiform deposits are formed. So zone 1, we have several zones. You have the Harshborgite zone. It's non-systematic distribution, meaning the chromite will be lesser. The next is the upper level dunite. Residual mantle materials where most ore are associated. And then zone 3 is the interlayered dunite and wurlite. These are actually concordant or subconcordant chromite bands. So basically, you still have chromite in all these zones, but the best zones where you can have the ore for chromite is your upper level dunite zones. Okay, next slide, please. And the next one is the residual and transported deposits. These are, as the term implies, residual and transported. So you can see this in laterite or beaches and placer sands associated with ultramafic exposure. So if your exposure has been weathered, eroded, and transported into your water bodies and eventually being deposited, then you'll have your residual and transported chromite deposits. Next. Okay, now we go to manganese. Okay, so rhodochrosite, this is the main ore. Okay, what is rhodonite? Can someone chat what rhodonite is? If rhodochrosite is the manganese carbonate, what is rhodonite? Yes, correct. Well, how about manganite? Yep, correct. It's a manganese silicate. How about manganite? How about manganite? You still remember? Oh, yes, it's a hydrous manganese oxide. How about pyrolusite? Pyrolusite is also a, yes, manganese oxide. Oh, you're very good. Okay, so these are the primary classification of manganese deposits. You have the primary and secondary, just straightforward. If it's primary, it's related to your volcanogenic or volcanogenic to sedimentary process. If it's sedimentary, if it's secondary, then of course it's not related to your volcanogenic processes. And there are also hybrids for this one. So next slide, please. So you have primary associated with agglomerates, tuff. These are the volcanics, plastic materials of subaerial to submarine hot spring affinity. So that's where your manganese is being deposited, deposited into your tuffs and your plastic materials from a hot spring. So it will form banded iron formation of distal submarine exhalate origin. So basically within the submarine environment. And secondary, it's non-volcanogenic, meaning it doesn't care. It doesn't have any affinity with any hot spring or any submarine exhalative structure. It's just a bog ore or lacustrine. What is lacustrine, by the way? What is lacustrine? If you just write the fluvial river, so you can see the difference. The primary is it has an affinity with a volcanic event or volcanic what do you call this? Volcanism. It's secondary, it's just associated with non-volcanic events. Hybrids, this is the one that I don't know if you have if still Sir Madrona still is teaching in USEP, but this we actually have these ferromanganese nodules in Catalunan. I think so. We went there. You can really see these manganese nodules up there. We went there for a field once with him, and then he showed us manganese nodules, and yeah, we tested it, and eventually those were ferromanganese nodules. It just tells you that area before was actually submerged or in the seafloor. It's been abducted through its geologic history. Excuse me, may I just drink water first? Okay, next slide, please. And now the exciting part. This is, for me, the exciting part. I haven't actually worked in a manganese or a nickel or a iron deposit before, but this is actually a little bit of my forte in terms of exploration experience. So we're not talking about the copper. I just put it in lump because basically copper, gold, base metal deposits are actually just interconnected with each other. So what are the types that we have in the Philippines? You have the porphyry, you have the skarns, you have the epithermals, you have the VMS, and we have this after all of this, and then in a superficial environment, we have the supergene enrichment of these types of deposit. Next slide, please. So porphyry copper plus gold plus molybdenum. What else? Those are the general ones. So it's basically a large, low to medium grade deposit, primarily of, if it's porphyry copper, of chalcopyrite, and if it is porphyry molybdenum, of course, it's molybdenite. And there are also some derivatives of porphyry gold only deposit. So it's that's gold is the primary mineral that you can exploit from it, which exhibits hypogene sulfide and alteration zone. So very important is, if you're going to target porphyry copper deposit, you must have to be very well versed about alteration zoning, alteration silicate zoning, because it will tell you, especially when you're mapping in the field, you'll just look into a specific outcrop, a very small part of that system, it will tell you where you are in the system. So basically, for porphyry copper gold deposit, chalcopyrite is the dominant economic copper minerals. Okay. But can you give me other minerals, copper minerals, that you can also see in porphyry copper deposit? What is the other minerals you can see? Just this question. What is the copper sulfide mineral that has the highest copper percent? Copper content or copper percent in the mineral, in that mineral? No? 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 Yes, Rosalie May, you're correct. It's chalcocite. I think it is 89% copper, if I'm not mistaken. So chalcocite. But why is chalcopyrite the primary ore? Why is chalcopyrite the primary ore? If chalcocite has a lot of copper in its mineral composition, why is chalcopyrite the primary ore? That is my question. Can someone answer, please? Correct. Very good. It's because of abundance and occurrence. Chalcopyrite is more common and more abundant in these types of deposit. Good. Okay. So we have prograde and retrograde alteration. And let's just next slide, please. Those are just specifics. The basic things you need to learn here is just, it's a large, low to medium grade deposit, which is primary, right, really of copper and molybdenite, and have hypogene sulfide mineralization alteration. Next slide, please. Wait, huh? Okay, go back, please. So I think you're already familiar with Silito. He is the god of porphyry for me. And his work is actually, can you go back one slide, please? is actually the Bible for porphyry, copper, and gold or other mineral exploration. Okay, so the plate tectonics model was the basis of the porphyry copper model in 1972. Then in 1973, a year after, the concept of a top and bottom part of your porphyry deposit was introduced. And then in the Philippines, 10 years or 11 years later, the porphyry copper model of the Philippines was conceptualized in 1984. So see, only a span of a decade that the Philippines has only been, the porphyry copper model of the Philippines was already been conceptualized, because most of our models here in terms of porphyry are classic textbook models or examples that you can see. Okay, next slide, please. So that is the infamous model, the anatomy of a telescope porphyry copper deposit or porphyry copper system. So important thing is it's a system, right? Meaning it has different functions with, and it has different parts which has its own different functions. So as you can see in that figure, you'll have multi-phase intrusion of porphyries, and then eventually those multi-phase intrusion, as it crystallizes, it emanates or it exsolves fluid that basically alters the country rock, alters the host rock, and other rocks within your host rock. And that is where your deposits are formed. And basically, he's saying that if you have a porphyry in a very ideal setting, if your porphyry is forming, and for example, if you have a carbonate layer that interacts with that porphyry, then you will form skarn. If it is within your porphyry, then you'll have endoskarn. If it is outside of your porphyry, within the layer of your carbonate unit, then you'll have exoskarn. And if it is further, its alteration is it's just an alteration based on a structure that intersects your porphyry towards those carbonate units, then you'll have your distal skarn and your carbonate replacement gold deposit. And immediately above your porphyry, the orange zone there, that is where your porphyry is. Immediately above that, of course, when your porphyry is degassing, when your porphyry is emanating those fluids, then eventually pressure will build up. And if that pressure builds up, if it's already what do you call this? Pass through the lithostatic pressure, then it will break the country rock. And if it breaks the country rock, then those fluids, those gases will eventually escape into those fractures, into upper levels or upper layers of the Earth's crust or of the country rock, and then eventually it will form different types of deposit. For example, the high sulfidation epithermal deposit immediately above the porphyry, and the intermediate sulfidation epithermal deposit further away from that porphyry, where there is a structure that cuts it. Okay. Important also, as I mentioned, is the alteration. You must have to know your alteration. So potassic alteration is, generally speaking, where the ore of a porphyry copper is. But for example, in the Philippines, if we don't have alkaline rocks, then of course we won't form that much potassic alteration. That's why in the Philippines, we'll really form those fluoride, sericite alteration as ore rather than the classic potassic alteration. So, okay, question: what is the key mineral when you say when you're talking about potassic alteration? Can someone comment in the section in the chat? What's the key mineral? Potassic. Okay. So your key mineral is actually biotite, secondary biotite, and K-feldspar. Okay, good. Potassic alteration, it's K-Felds and secondary biotype. Okay, when you are talking about okay, that's it. So alteration, you have potassic, and as it goes up, the zonation is also an effect of the neutralization of that fluid coming from your degassing or exsolving from your magma. So as you can see, we have that central potassic, and as the fluid emanates outward, then it's being neutralized by meteoric water or your groundwater, and then you have those other types of alteration. Okay, next slide, please. Okay, next is skarns. So basically, again, skarn, these are copper, base metal sulfide plus gold, talc silicate, contact metasomatic rocks. So we have types, we have the porphyry-related, proximal versus discal, endo versus exoskarn. You can just study that one specifically. Skarn, basically, you have an intrusive. The intrusive is emanating or exsolving, and then if it goes in contact with a calcareous or a calcic unit, then eventually it will alter or it will alter the and deposit the precious and base metal rocks minerals within your porphyry with your intrusion or within your calcic unit. So next slide, please. Okay, that's the formation. You have the isochemical skarn. What does isochemical mean, by the way? Who knows what isochemical mean? Isochemical. Who knows what chemical? Who knows what the meaning of isochemical? Actually, isochemical, it's an alteration where the bulk composition of your mineral bulk composition is not changed. No change, no addition, no subtraction of bulk elemental composition in your, for example, in that skarn phase, no? But next slide, if you're going to say metasomatic, there's already an additional change in the bulk metal composition. Retrograde skarn is basically when your meteoric waters are descending towards your exsolving or skarn front, then you'll have your retrograde skarn and mineralization. There's a function already of alien or outside from your system, which is the meteoric water coming into the system. Okay, next slide. Just a photo example of a skarn. Okay, so can someone tell me where the garnet is there? What color is the garnet? Is it the black? Is it the brown or the flesh color? Is it the yellow color? Which is garnet there? Is it the white? Is it the black? So it said that this is a prograde garnet pyroxene skarn with magnetite veinlets cut by retrograde actinolite epidote chalcopyrite skarn. So in that picture, which is the garnet? Yes, correct. That's the garnet, the brown one. The black one looks like a vein. That's the magnetite. The chalcopyrite is within the fracture fields. You can see the yellow ones, the yellow colored ones. Okay, next slide. Okay, epithermal gold. Yan. Those of you who work in Philsaga, you'll know that it's an epithermal gold deposit. Okay, so definition, it should be hydrothermal deposits formed at low temperature, usually shallow depths, less than 2 kilometers. That's it. Straightforward. Low temperature, less than 300, actually less than 240, but sometimes there are deposits which are having 300 plus temperature. And it is formed, paleo environment is less than 202 kilometers. Examples, you have Lepanto for high sulfidation, intermediate sulfidation, and low sulfidation. Philsaga, do we have OJTs from Philsaga here? Or no? Do you still have OJT? Doing on-job training on mining companies. So Philsaga Mining Corporation is an intermediate sulfidation deposit of epithermal type. Okay, so next slide, please. Next slide. That's just basic. Okay, so for the type of epithermal deposit, the oxidation state, you'll see intermediate is just oxidized, high is very oxidized, and low is reduced. And then, okay, just to for the description, what does high, low, and intermediate sulfidation mean? Does that mean it is in terms of the number or amount of sulfide minerals present? Yes or no? For example, when you are say you just say if this statement is true or false, true or false. High sulfidation epithermal deposits are deposits which are referred to as epithermal deposits which have higher amounts of sulfide rather than intermediate sulfidation epithermal deposit. True or false? So is it the amount of sulfide? Again, is it the amount of sulfide? Actually, in this what you call this, in this table, it looks like it, no? But basically, it's false because sulfidation in this in the sense of sulfidation here it is about the sulfidation state of the sulfides. It's not about how many or how the amount of sulfide present. It's about the sulfidation state. If the state is of the sulfide is high, then you'll have high sulfidation deposit. So what are the high sulfidation state sulfides? Can you name? For example, meaning what are the sulfides which you can see in high sulfidation epithermal deposit? What are the key sulfide minerals in high sulfidation? Okay, good. In intermediate sulfidation, what do you see? What is the key mineral? Yeah. How about low sulfidation? Correct. Oh, gyro. Very good. Actually, it's there already, no sulfide complexes. Okay, next slide, please. That's it. Thank you. So, what else? Location, just next slide. This is just a presentation of the largest epithermal gold silver deposits in Yanacocha, in Peru, I think. Next, high sulfidation. Next, okay, these are the textures that you will see in high sulfidation epithermal deposit. You will have magmatic hydrothermal breccias. You'll have steam heated alteration. What is that texture in the upper left corner? What do you call that texture? What do you call that texture? The upper left corner. What is that texture? Yep, very good. Vaggy texture. And it is indicative of acidic environments where all other minerals except of quartz or silica was leached, and then silica was the one that remained. Next slide, please. Okay, another vaggy texture of quartz ore in the Panto in get high sulfidation epithermal deposit. Okay, next. Intermediate sulfidation, carbonate base metal gold deposit on some people. I think it was intermediate sulfidations are the ones that are being termed and classified by the magmatists. It was Silito, it's Hiddenquist, and then carbonate base metal gold is actually the one that is being coined by Corbett and Leach. Okay, so examples, yes, meaning these are fracture filling, vein type deposit, which you will have those carbonate minerals in deposited together with your base metal, sphalerite galena. And of course, that's where the gold is. Next. Okay, iron-rich sphalerite plus chalcopyrite veins inside. Okay, these are just examples of these intermediate sulfidation. It's Kilian in Indonesia. What is that? It's okay. Okay, so what does the color of sphalerite mean? For example, sphalerite has a range of colors from yellow to dark brown to dark sphalerite. What does that mean? Generally speaking, what does that mean? What does that indicate? When you see, for example, a yellow sphalerite or an orange sphalerite, yes, correct. It's the amount of iron and zinc within your crystal structure. What else does it mean? What does that indicate in terms of the formational environment? It means it's actually a geothermometer. Sphalerite is actually a geothermometer where your lighter colored sphalerite indicate a lower temperature formational environment, and your darker colored sphalerite indicate higher temperature formational environment. Next slide. Low sulfidation. You'll see it's the prominent texture of low sulfidation epithermal deposits are the crustiform coliform banding. And what is the key gangue mineral? Who can type the key mineral, gangue mineral for, if you see that mineral, that alteration, then you are quite sure that it's already in low sulfidation. Wood. Yep, adularia. Okay, next slide. VMS. So we're now VMS. We're almost done. So VMS deposits. Okay, massive sulfide deposits associated with submarine volcanisms and related sedimentation. So very straightforward definition. If it's all about submarine volcanism and you have deposits and subsequent sedimentation after, and you'll have this, we have massive sulfides that are deposited within it. It's volcanogenic massive sulfides. It's just straightforward definition. So you have types: the Cyprus, the Kuroko, and the Beshi. Next slide, please. Okay, you can just review this, the types, and then which is their occurrences. The Cyprus is in ophiolitic complexes, the Kuroko is in back arc, and the Beshi is in extensional environments. So yeah, you can just look at this table and then familiarize it. It's just straightforward definition and of the types of deposit. Next slide, please. Examples, yes, Kuroko in Samar, Cyprus in Zambales, and Beshi is in Camarines. Those are the tonnages for those type of deposits. You have copper, you have zinc, you have silver, you have gold. Very good classic examples of the VMS deposits. I haven't been there. I haven't actually seen a VMS deposit, so I really cannot expound or elaborate too much on this. I apologize. Okay, next slide. The location of the Philippine VMS deposits. Again, it's located in ophiolite or ophiolitic sections or areas in the Philippines. So one question, why do you have VMS in central Mindanao? Actually, that was also a question I was asking before, because you see ophiolite sequences. Where does ophiolite sequences generally occur? Where does ophiolite sequences or ophiolitic sequences? Okay. Yes. Okay. So when you see that there is a VMS deposit in the central of Mindanao, yeah, that's Bukidnon, right? That area there. Therefore, we can generally, theoretically conclude that there is a subduction zone there before. No, that's just, I don't know. I haven't read I think there is, because there is an ophiolite sequence there. There is an abducted section of your oceanic plate that's been deposited or abducted on that area in the central Mindanao. Okay, next slide. Okay, supergene enrichment. Supergene copper enrichment, it's basically when you have the weathering of your copper-bearing minerals, and eventually the copper is leached and then redeposited into a higher grade deposit. But of course, smaller volume because it's already been remobilized. So at the water table. Okay. So examples, many of the porphyry copper deposits in arid environments pose their economic availability or high-grade copper to this phenomenon. Because, for example, you drill the copper deposit and it's really not economic, but because of supergene enrichment, the copper from the porphyry copper deposit has been leached due to weathering and then redeposited to the water table, forming a blanket of copper-rich environment or copper-rich blanket. Then that makes your prospect more economic. So next slide, please. Okay, so that's how it forms. You have a leach zone. Eventually, because of your weathering and permeation of your meteoric water in a structure or in a porous environment, then your metals will be removed. Then, of course, due to the work of gravity, eventually it will be deposited into the supergene copper sulfide zone, which you will also have a supergene copper oxide zone because of the oxidation of those sulfide. Okay, next slide. Okay, now we go to non-metallic. After the metalliferous, of course, the Philippines is also blessed with non-metalliferous resources. So I just put this, just a quick review for this one also. This might also come up in the exams and the board exams. So industrial minerals and manufacturing minerals, what are the materials of the examples? You have asbestos, you have barite, you have bentonite, clay. Those are the most important things. Limestone, gypsum, feldspar. Yeah. Next, structural and building materials. Of course, if you have, because before the former president have the build program, then we need a lot of this. You have the marbles, the pumice and pumicides, you have the rock aggregates, asphalt for our road, sand and gravel, and volcanic tuff or the adobe. Very important. And we all have that here in the Philippines. Next slide, please. Gemstones and decorative materials. Okay, the Philippines is not actually that quite known for gemstones because the most precious gem in the US are cratonic environments, but we also have our own share of these gemstones and decorative materials. For example, what they call the Zambales jade. Actually, it's not actually a jade. It's a uvarovite. What's a uvarovite, by the way? What is uvarovite? Anyone knows what a uvarovite is? What is a uvarovite? Yes, correct. It's a greenish variety of garnet. Actually, it looks like an emerald. It's emerald. Looks like an emerald, but it's just garnet. Okay, the Mindoro jade. We also have that one. We have some jasper and chert, of course, because of our formational environment. We are in a oceanic setting and then basin. And then these jaspers and chert forms, and then eventually through time, it becomes more lithified, and it develops into a harder rock. Then we have agates also in volcanic regions. And then we have this garnet, feldspar, amethyst, nepidote. Actually, these are semi-precious gemstones. We also have petrified wood. Yeah, I have a lot of petrified wood in Agusan del Sur, actually, where I came from. Okay, next slide. Also, we have fertilizers. We have the guano, which is accumulated excrement and remains of birds and bats, for example, in caves. We can use those and process those as fertilizers. Very important also for generating or manufacturing chemical fertilizers are the phosphate rocks. We also have that here in the Philippines. And also, we can also mix the limestone, dolomite, and magnesite in fertilizers for our farms and for export also. You have peat, the dark brown to black carbonaceous residuum produced by the partial decomposition and disintegration of organic matters in marshlands, lakes, and tidal flats. So in the Philippines, we have that. Actually, that is actively forming in, say, for example, in Agusan Marsh. So we'll have that peat deposits there. Young peat deposit, but eventually they will become peat sooner. Maybe not in our time, but And we also have sulfur deposits, which are basically byproducts of copper mines and several natural sulfur deposits in the Philippines. Okay, so I think that's the end of my presentation. Thank you very much. Any questions? Are you still there? Yes, can send a copy of the presentation. From Jairo Lloyd, please tell us about the overview of deposit in Laos. Okay, for Phobia mining, we are actually for me, in reports, they said it's a porphyry copper deposit, but for me, it's not, because it's not a classic porphyry deposit because you don't see the alteration. So you can just say it is a porphyry-related deposit. But most about also the deposits are formed in skarns. So we have copper gold skarns here. That is in my area. Generally, you'll see that all throughout Laos. The problem here in Laos is because it's a very old terrain, it's a cratonic terrain, therefore the metamorphism of the rocks, the deformation, very difficult to identify the rocks already, especially if it's been folded many times. You'll see shearing, too much metamorphism, and then it's difficult actually to identify the original rock. So usually we send petrographic test for the rocks here. But here in our area, usually we are looking for skarn and porphyry-related mineralization. One area also is a base metal, subvolcanic, epithermal type, vein type mineralization. Some more questions? No, it's not actually. It's not molybdenum rich. No, it's not. It's not related to any molybdenum deposit actually. We're looking at the granite, but the granite doesn't. It's actually very old, and it's not that altered. It's sericite altered, but it's not the main cause of mineralization. It can be an indicative of continental affinity. The molybdenum, yes. What else? So we have a lot of we're 55, so you can just throw in questions. Any questions? Anything, even if it's not related to the presentation, as long as, of course, it's related to our profession. Still have any question? Maybe I give the floor back to the secretariat. What's her name again?
Hi, good evening, sir.
Good evening.
Okay, wala na ba yung question from reviewees?
Wala na yung pangutana?
Final na, guys. Ay, may
I'll just give you the presentation. If you have further questions, clarification, then you can email me and then just send them my email address.
May pahabol pa po na question si Kuya
Okay,
Dayo.
sige, go. What did he ask? Actually, yes, because we are thinking about our deposit here is actually related to the Loy fault corridor. So yes, yep. Especially that Laos is actually in the middle of the Southeast Asian section. So you have Thailand here, you have Cambodia, you have Myanmar, and Laos is in the middle. Therefore, the structural regime in Laos is very, very complex. Yeah, I think so. Here in Laos, most of the mineralization is structurally related. That's why sometimes it's really very difficult to follow it in terms of drilling because it will be confused. There's no one structure where you can blame where the mineralization is occurring because there are several events that cause faulting, folding, shearing, those kinds of events. Yes. Mineralization generally dips to the north, plunging dips to the north, east-west. Yeah. But there are minor mineralization that's generally trend northeast. There are also mineralization in some area that generally trends west. So it just depends upon the dominant structural regime during the time of when the hydrothermal fluids or the pregnant hydrothermal fluids were in place. It's really not there's no one trend, but it depends upon the area. Therefore, you just have to follow the major structures first if you want to target and vector for mineralization. It's generally structurally controlled. What else? Thank you very much. It's my pleasure.
Okay. Wala na po ba yung mahabol na questions, everyone?
Katugon na sila kaya sa alas 9 na ba diha?
Yeah. So, okay, so thank you everyone for attending our lecture today. And thank you so much, Sir Rojan, for the invaluable insights you have shared today. On behalf of everyone present, I would like to extend our deepest gratitude for your time, expertise, and the knowledge you have imparted to us. Your passion and dedication have truly inspired us. So, as a token of our appreciation, okay, we would like to present you with a certificate. It serves as a small symbol of our immense gratitude for your contribution to our review and to our personal and professional growth. So, let me read the citation part. Certificate of Appreciation is given to Rajan Muad for guiding the reviewees in preparing for their board examination and sharing his invaluable insights and expertise as a lecturer on mineral resources of the Philippines during the SUG Geology Board Review 2024 on the 16th of September 2024, signed Mayor Intanya, the SUG President. Thank you once again, and we look forward to future opportunities to learn from you, sir. And before ending the lecture today, I would like to request everyone to please open their camera so that we can have an photo opportunity with sir. Please show your smile, everyone. Okay.
Smile down.
Smile kayo, guys. Okay, ready? 1, 2, 3, smile. Another.
Okay.
Okay, all done.
Good.
So,
Thank you very much also,
sir.
no? Thank you very much, Sug. And all of the reviewees, there are a lot, 55, no? So good luck to the exam. My only advice is aim for the top. That's it. You will never go wrong.
Thank you so much,
Thank you.
everyone.
Salamat sa lahat.
Thank you again,
Thank you,
Thank you very
sir.
much. Thank you. See you around
Thank
in
you, sir.
Davao. If I'm in Davao, then we'll have time to chat or meet, no? Ano kailangan ng mga bago nga, mga ano, mga...
Thank you, sir.
Sige. Okay, good night, everyone. Thank you very
Sige po,
much.
sir. Thank you again.
Sir.
Bye.